How hackers steal the data using DNS traffic. Imagine this. A computer has a firewall. Here it is the firewall, and the company has IDS, IPS, and only trusted DNS server are allowed, like Google DNS server or internal DNS server, etc. etc. Everything looks secure, and but one day sensitive data is stolen. No suspicious website was opened, no file was uploaded, no direct connection to that attacker was found. So how did the attacker steal the data? The answer is DNS traffic. Okay, here it is DNS traffic. So before we understand the attacker, let's first understand how DNS works. So first of all, we are discussing about that what is the DNS. DNS stands for the domain name system. So port number is 53, and DNS allows like a phone book for that internet. So when you type google.com, so your computer does not know, okay, does not know where that Google is. So your computer only understand that IP address. So your computer sends the DNS request to the DNS server. So what is that IP address of google.com? So that your computer asks to the DNS server, okay, what is that google.com IP address? So the DNS server replies, okay, the DNS server replies, and this is that google.com IP address. So now your computer connects to that Google and opens that website. Simple. Okay, normal DNS is used only to find that IP address. Okay, here it is normal DNS flow. Okay, user opens google.com, computer sends DNS request, and DNS server replies with address and website open. That's it. Okay, this normal flow. Okay, and the next one, it is that what is DNS tunneling. Okay, here it is what is the DNS tunneling. So DNS tunneling is when attacker misuse DNS traffic to transfer the data. So instead of using DNS only for IP address lookups, attacker had the data inside DNS request. So here it is that normal password at the rate of 1234. Okay, here it is normal password. So for example, this is about this a malware infected computer. Okay, here it is computer, it is affected with that malware. So the malware steal that password and customer data and sensitive files, all of these. So now the attacker wants this data, and but uploading files may be blocked by security controls. So the attacker uses DNS. Okay, DNS tunneling. So how does DNS tunneling work? Okay, let's say the malware steals the password, and the password is the rate of 1234. It is that password. So instead of sending it directly, so the malware hides it inside a DNS query. Okay, so the malware hides this password, okay, inside the DNS query, and now the computer sends the DNS request. Okay, now that computer sends the DNS request to that Google DNS server. So at first glance, it looked like a normal DNS request, but hidden inside that request is stolen the data. This is DNS tunneling. Okay. That normal question is, many companies allow only trusted DNS servers such as Google DNS or internal DNS server. So how can that attacker receive the data? So this is where many people get confused. So the infected computer does not directly connect to that attacker. Okay, the infected computer sends the request to only to that allowed DNS server. Okay, for example, here it is computer, and here it is Google DNS server. So the firewall sees, okay, the firewall sees the computer to that Google DNS server. It looks like normal, so the firewall allowed it. So then how does the attacker get the data? So the computer sends password 1234.attacker.com. So okay, it is the attacker website. So attacker create that fake website. Okay, and the next one, it is that malware send a request to that Google DNS server. So the Google DNS now tries to find that information about this attacker.com. So that Google DNS server search, okay, is the Google DNS server search it in internet. Okay, where is that attacker.com? So to that Google DNS contacts to the DNS server responsible for attacker.com. So the DNS server belongs to that attacker. Okay, this DNS server belongs to that attacker. So now the attacker receives password 123.attacker.com. So and extracts the hidden data, and this is the most important point. The victim never directly talks to the attacker. The victim talks only to the trusted DNS server. Okay, that is internal DNS server or Google DNS server. Okay, I will show you one more thing. So packet captures. Okay, here it is packet capturing by Shark. Okay, here it is google.com. Here it is infector system IP address. Okay, here it is normal DNS query for google.com. It is normal DNS query. Here it is malicious DNS query with encoded data base 64. Okay, here it is. And why does not the firewall stop it? The firewall sees computer to Google DNS. Okay, the computer to Google DNS. The destination is trusted DNS server. So the traffic looks like DNS traffic. So the firewall may allow it. And the firewall does not always the firewall does not always know that hidden data exists hidden inside the DNS query. So that is why DNS tunneling can sometimes bypass basic firewall rules. And what about that IDS IPS? Okay, IDS and IPS can inspect DNS traffic. They look for suspicious activity. For example, very long DNS request, random characters, and large number of DNS queries, and strong domains and strange domains. Strange domains. For example, here it is. Okay, it's look like that very long DNS request and random characters and large number of DNS queries and strange domain. Okay, attacker.com, it is the strange domain. Okay, for example this one, and this look like suspicious. So IDS may generate an alert and IPS may block the traffic and raise an alert to the security team. So then why does not IDS always detect it? Because the attacker are clever. Okay, instead of the sending that password at the rate of 1234, so they may send ab.attacker.com, cd.attacker.com, or ef.attacker.com, gh.attacker.com. So each request look like small and normal. Okay, a single DNS request may not look suspicious. So because of this, same DNS tunneling activity may bypass signature based detection. Okay, that IDS IPS is mainly work based on that signature or behavior base. Okay, this IDS and IPS is working on both. So how does a SOC analyst detect the DNS tunneling? So SOC analysts do not look at only one DNS request. So they look at pattern. Okay, for example, a computer sending thousands of DNS requests. Okay, the computer sending the thousands of DNS requests, the same DNS appearing. Okay, so there is that same DNS server is, the computer sending the thousands of requests to that DNS server. So the computer sending thousands of DNS requests, the same domain appearing again and again. It is long DNS queries. Okay, random strings and rare domains and unusual DNS activity. So by analyzing DNS logs and SIM alerts, SOC Analysis can identify DNS tunneling attempts. And the difference between that, this is the DNS tunneling and next one it is the DNS. Okay, what is the difference between the both? So that normal DNS, its purpose, it finds that IP address, for example google.com, and the result website open. And next one it is the DNS tunneling. So DNS tunneling, it means main purpose is transfer hidden the data. Okay, for example this, okay, password at the rate of 134.attacker.com, it is the hidden data. So that result, the final result is data reaches the attacker. Okay, this is one. Okay, and final last summary. Okay, final last summary, it means DNS was created to convert domain names into that IP address. Attacker abused this trusted protocol to securely transfer the data. So the infected computer does not directly connect to the attacker. Instead of it send DNS request to the trusted DNS server. Hidden data is placed inside those DNS requests. That is why DNS tunneling is considered a dangerous data exfiltration techniques. So, and that is why SOC analysts closely monitor DNS traffic to suspicious behavior. Okay, and uh, and anyone have that any doubts, so please ask me. I will definitely give that response and clarify your doubts. And please, okay, if you are satisfied this video, if you are like this video, please subscribe, share and save this video. Okay, bye.